Hi everyone, welcome back to my channel. Today we're going to talk about scatterplots and correlation. So first off, we need to know what a scatterplot is. So a scatterplot is used in statistics to represent bivariate data, and it's qualitative or numerical data. Bivariate means two variables. And then we represent one on the x-axis and the other on the y-axis. So this data here is mean study time versus mean test scores. So average study time versus average test scores, two different variables. A scatter plot displays data on a grid using an x and y coordinate. So in our case, our x would be the mean study time and the y would be the mean test scores. If the y tends to increase as x increases, like this data right here, so x increases and y increases, then the data, let's see, so x increases, y increases. They both go in the same direction. This is a positive correlation, okay? If the y data decreases and the x data increases, this is a negative correlation. So it looks something like if the points were like that, the graph would be going downward, okay? So we can look at a scatter plot and know if the correlation is positive or negative. So if the slope is positive or the slope is negative, or if it's like really strong data or if it's kind of weak. So a strong negative correlation would look something like this. So you can really tell that the line is going in the negative direction and the points are really close together. A strong positive correlation would be something like this. Okay, it's really easy to tell that this is a line. A positive weak correlation would be something more spread out. Okay, so maybe not. Okay, so you could tell that this line is going in the upward direction, but the points are further away from the line, okay? The next part is a weak negative correlation. So same thing, downward facing line, but the points are more spread apart from the line. Our estimation line here, okay? Our next one would be no correlation. So this is like when I can't tell if the graph is positive or negative. So I can't draw a line of best fit here. A couple things to note is direction for a correlation is determined if by our R value, which we call our correlation coefficient, which is represented by R. So the direction is shown by if the R value is positive or if it's negative. If the R value is positive, we have a positive correlation. And if the R value is negative, we have a negative correlation. So it looks kind of like this. The strongest correlation would be R is equal to 1. And the weakest would be, or also strong would be R is equal to -1. No correlation is right here in the middle at R is equal to 0. So if I make a number line here, a strong positive correlation would be an R value that is between 0.8 to 1 and also from -0.8 to 1 is a strong correlation. A weak correlation would be from 0.8, I know this is not exactly perfect, to 0.7. This is weak. and then from 0.7 to 0.8 is weak, and in the middle is no correlation. And I wrote up some notes right here. So from 0.8 to 1 is strong correlation, from 0.7 to 0.79 is a weak correlation, and anything below that is going to be a no correlation. So if I look at the next ones, we're going to state the direction and the strength of each correlation. So R is equal to 0.93. That is between 0.8 and 1. That is a strong correlation. And is it positive or negative? It's positive because the R value is positive. Go ahead and work on the next 4, and we're going to go over those in a second. This second one, the R value is negative, so it's a negative correlation. And it is a value between 0.8, or the absolute value of 0.8 and the absolute value of 1. So this is also a strong correlation. This one is negative and weak because it's between 0.7 and 0.79. This one is positive because the value is positive and weak. Ooh, and no correlation, sorry, because it's below 0.7. This is a positive and perfect because all the data is going to be on the line. Okay, the next ones. Based off of the graph, what's our direction and our strength? So I can see the direction of the points are negative. As x increases, y is decreasing. And if I draw in a line right here, the points are really close to it, so this is going to be a strong correlation. The next one is all over the place, so no correlation, no direction, and it's not strong or weak. Okay, again, this one is positive. Are the points close or far away from the line? They're close, so this one is likely going to be strong. It's hard to estimate without an R value, but we can kind of guess based off of the graph, okay, what the strength of the R value is going to be. So the last part is we're going to look at the data. So the data compares, here's the data. The data compares TV time per night versus test scores. What is the direction and strength? I'm going to estimate that the direction is negative because the graph, as TV time increases, the test scores are decreasing. And the points are pretty close together, so I'm going to say that it's strong. Though we could make an argument that it's in between strong and weak, okay? Kind of medium. So estimate the correlation coefficient. I'm going to say it's like 0.8. So kind of on the verge of being weak. So what is the shape of the graph? We're going to think, is it linear, quadratic, exponential? I think this data looks mostly linear. Right? So I could draw a straight line through it pretty easily. And in fact, we're going to go ahead and draw a straight line through it. And you're going to want to make sure that we get about half the points above and below the curve, and that the slope matches the points as best as we can. So it is an estimation. So I'm going to be like, I think I'm going to go in about right there. Maybe, yeah. Kind of like that. Some of the points are going to be a little high and some are going to be a little low. I'm going to move this a little bit so that they're like that. Okay, something that's pretty close. So what this line is called is the line of best fit. So it's not going to go through all the data points because this is not a perfectly straight line, but it is a good estimation of what we have going on with our information. So we use a line of best fit to make a prediction or estimate based off the data of the graph. So we're going to do that now. If a person watches 2.5 hours of TV per night, predict what the test scores will be. I'm going to go to 2.5 and thank you, Siri. Okay, 2.5 and up to the line. And I see that that is about 22. The score is equal to 22. When I win, I watch 2.5 hours of TV. Now, if you watch 2.5 hours of TV, it is possible that you could get a score of 40 on your test. But according to our estimation line, we predict that the score is going to be about 22. We're going to do the next one. So what do you predict the score to be when you watch 1 hour of TV? So 1 hour, go up to the line, and I get about 34. Is it okay if your scores are a little different than mine because your line is a little different than mine? Yes, as long as your line of best fit matches the slope and is about halfway between each one of the points. Okay, so lastly, we're going to go backwards. If your score is 20, okay, so if my score is 20, I'm going to draw it over and then down. So about 2.75. So 2.75 hours per night. And that's all we're going to do for right now. If you're in pre-calc, we're going to look at this stuff later. And if you're in Math 1, we're going to look at this stuff a lot later. Or we're going to expand upon this information a lot later. Okay. That's it. See you tomorrow.